All right, guys, good morning. My name is Sid. I'm the director for the graphics and advanced visualization team at Solidworks. Today, we're going to be talking about graphics performance improvements in Solidworks 2020. So the agenda for this talk is, let's go over the kind of problems we solve with enhanced graphics. We'll take a look at some of the performances that we see in assemblies and parts. We'll also take a look at performance in drawings. We'll take a look at graphics card requirements and driver requirements. We'll give us a little bit of sneak peek at some future improvements that we are looking at, considering, and then it's time for some QA. All right, so first of all, before we talk about enhanced graphics, let's talk about what exactly is enhanced graphics. And for some of you who may have known, we called it internally the render pipeline project. So you might have seen in some places called it the render pipeline. So the render pipeline project is a rewrite of the entire graphics rendering engine, and it's a multi-year initiative by SolidWorks to bring the best performance and image quality for our users. A lot of our customer asks were resolved with the render pipeline project. So the first thing that we did was to remove the CPU bottlenecks. We removed a lot of CPU bottlenecks that prevented the GPU from doing its job. CPU bottlenecks are usually characterized by expensive computations that's done for every frame at the time of render. By removing these computations or making them more efficient, we minimize disturbing the GPU from doing its job at full potential. We also had to rethink about some of the operation performed on the CPU, and we tried to do these expensive operations on the GPU rather than on the CPU. And this brings me to the next point on model data, keeping the model data on the GPU. Early releases of SolidWorks had the tessellation data on the GPU, but with 2020 onwards, we keep a lot more information on the GPU, resident on the GPU. This allows the GPU to perform as fast as it can and without any disruptions from the CPU. And this helps in scaling. And the important thing out here is that it scales across different models and generation of GPU releases from all the way from low end to high end. And being a GPU bottlenecked is actually pretty good, because then you're utilizing all of the GPU cores, or sometimes people call them CUDA cores. In fact, we see a performance across GPU generations that is exponential, not just linear. And we had to also switch our thought process, to modern paradigms in graphics rendering. And we had to look at other industries. Today is the world of big data, and big data is available in several other industries. So we had to bring some innovations from other industries to our graphic rendering in SolidWorks, and that's why you see this massive improvement in performance. And we went to great lengths to design the new rendering engine to be future-proof. We worked very closely with nVidia and AMD to make sure that the render pipeline is optimized to work on their drivers, so that you, our clients, user base, get the best performance and image quality. So how do we enable the enhanced graphics performance option? If you go to the tools option, tools and then option, and then there's a checkbox to enable or disable it, it's called Enhanced Graphics Pipeline, and it requires a SolidWorks restart. In 2019, in SolidWorks 2019, this used to be a beta feature, and you had to explicitly turn it on to utilize this. Whereas in SolidWorks 2020, it has been turned on by default, but you still have the checkbox to disable for any as a safety net. Now, there are a few things that you should be aware of. First of all, users who are using the render pipeline or the enhanced graphic should be aware that this is bleeding edge, cutting edge technology that we have incorporated in SolidWorks. You would have to download the latest SolidWorks certified graphics driver from nVidia or AMD, as indicated at our certification webpage. And there was a talk yesterday by Jeremy, and he would have mentioned about the certification, hardware certification. Now, the render pipeline is also disabled if you have an NVIDIA Quadro and the driver is less than 391.89. So you must be very careful that you get your certified drivers. It's also disabled for CATIA profile in NVIDIA control panel. How many of you know about NVIDIA control panel and how to set profile settings and stuff like that? Okay, quite a bit of you. All right. So that's something to take into consideration. And it's also the enhanced pipeline, the graphics performance is also disabled on Intel integrated graphics. We always go with the discrete graphics card. All right. This is just a suggestion from Solidworks and also from NVIDIA. If we would like if you guys actually use the base profile on your control panel. Previously, when it was during the time of SolidWorks 2019, there might have been some word put out to use dynamic streaming, workstation dynamic streaming. But it's actually, if you guys have your graphics drivers certified, installed at a certified version, then it is highly recommended that you use the base profile if you're using only SolidWorks to maximize for stability and performance. And I must stress on the installing the latest graphics card drivers because we work very closely with the vendors, with graphics card vendors like NVIDIA, and bring out performance improvements on the driver side. So you wouldn't be able to see these performance benefits unless you install them. So just as an example of, let's take a little bit deviation and talk about image quality. So in 2019, without the render pipeline, we had an implementation of SSAO, or ambient occlusion. How many people are familiar with real view and ambient occlusions? Okay, awesome. So one of the great technologies that we brought along with the render pipeline is a brand new implementation of ambient occlusions called HBAO, or horizon-based ambient occlusions. This is something that we worked with NVIDIA together, and it's almost free. So before there was a time where the ambient occlusions were, or precise quality ambient occlusions were not there when you were in dynamics. Now you have ambient occlusions with the dynamics. So and performance doesn't degrade. And that's a very important thing to understand. The performance between real view and non-real view is almost sort of an aesthetic thing rather than is it bad or worse. And if you do find situations, that is slowing that you're not expecting, come get with us, and we'll resolve. But with maximizing the capabilities of the GPUs, we are pushing through normal level of details. We are pushing through maximum image quality, and you're getting the performance. So as an example, I just talked about level of details. Before in SolidWorks, without the render pipeline initiative, if you were to rotate the scene when in dynamics, it used to go into this level of details that sort of is a coarse representation of a mesh. With the render pipeline on, we don't do that any longer. It's always going to be rendering at full resolution, at maximum performance, trying to push the GPU as much as it can. And this is, while we push the GPU so much, this is where also the scaling of performance also comes into play. If you buy a graphics card that is of higher end, you are going to get a performance increase. And if you take a look at some of the numbers for assemblies and parts, let's take, this is the CFH telescope model that we can show publicly. We have around 6,800 odd parts, components. There are about 22,000 bodies, and well, from benchmarking, I know it's got more than 16 million vertices. And you can see that for comparing apples to apple, this is legacy with turning off the level of detail, and because the render pipeline doesn't use a level of detail. You can see that the light blue bar out there represents the legacy. The gray one represents 2019 SolidWorks with the render pipeline in beta, and then the dark blue is the render pipeline in SolidWorks 2020. And you can see that there's a nice scaling in performance. And this was a benchmark that was done in resolve mode and in non-real view. So for performance in drawings in 2020, we worked on some really cool performance improvements. And you can see on the left-hand side, it is 2019 without the render pipeline. And you can see when you're resizing the window how slow it is. But on the right-hand side, if you resize the window, you can see how smooth it is. And not only that, but if you also zoom in to the model, you'll find that it takes a bit of time to reappear and to do the full rendering, whereas with the render pipeline, as you zoom in and zoom out, the rendering is very much kept in persistent. The other side effect is that highlighting of some of these edges in the legacy took a bit of time, but with the performance improvements, it is immediate on the right-hand side. And another improvement that we saw with drawings is that on the left-hand side, again, without the render pipeline, when you drag the drawing views, the rendering was unable to keep up with, so the model used to disappear. With the render pipeline, you find that there's a continuous render, and it's actually really smooth. And that was talking about image quality on drawings. I'm not sure if you can actually see through this out here, but from the distance, you can see? Yeah, there's pixelations, okay. Yeah. So this is some of the great work that we did with the annotations. The legacy text had some, and this isn't just an anti-aliasing technique. It is actually a brand new technique that does not, actually much faster and better in quality than in unanti-aliased text version. And the good thing about this implementation of annotation is you could have a 720p monitor, or 1080p monitor, or 4K. It doesn't matter what resolution you have, your text is always going to look crisp, no matter what. And there is no performance degradation out here. In fact, it is improvement in performance. All right, so let's talk a little bit about graphics card requirements out here. We consider that, well, there are consumer graphics cards, and then there's enterprise entry level, there's mid range, and then there's the high-end graphics card. For consumer grade graphics cards are mostly meant for enthusiasts and hobbyists. They're typically found in low-end devices like maybe Wacom tablets, which have discrete nVidia cards. Consumer grade graphics cards are also GeForce cards that Solidworks doesn't have support for real view, that don't certify for real view. And graphics card drivers can, improve the performance of the graphics card end. And so, with the low end and next generation graphics card, you can get better improvements in performance. So let's just go over the consumer. You have the P400, P600, P620, the Pascal ranged. And how many of you actually know about, the different generations of nVidia? Okay, let me explain. So the render pipeline is supported for any graphics card that supports OpenGL 4.5. So when you look at your graphics card list, that's the first thing you should look at to see if it supports OpenGL 4.5. On nVidia, this starts from Kepler. So you have Kepler, then you have Maxwell, then you have Pascal, and then you have all the physicist names, right? And then you have, from Pascal, then you have RTX, and between RTX and Pascal, you have Volta, the GV100. Yeah, which is an awesome card. I can't say enough about that card. But let's just go through the entry level, what I think is the entry level card. I think at a minimum, right now, if you were to purchase a graphics card, at a minimum, I think you should purchase a P2000 or a P2200 for testing, or on a budget constraints or something like that. And then the Maxwell, the M2000 and the K2200 are also supported. The mid-range, I would consider an RTX 5000 or a 4000. If for a Pascal, it's a P4000 or P4200 and a Maxwell M4000. But I personally, if you were to ask me if you're purchasing a brand new card, I would go with an RTX 5000 or 4000. And the high end graphics card, I would say is the RTX 8000 and 6000. And there's really no difference between an RTX 6000 and 8000 other than the size of the memory. So if you're doing like high, like Hollywood style, or doing some renders that requires large frame buffer sizes, then you would go with an RTX 8000, which has got a 48 gigabyte of frame buffer size GPU memory. With an RTX 6000, you have half of that, 24 gigs. Then you have the GB100, which is, a lot of people use it for visualize, but it's still one of my favorite cards. And a P6000 or GP100 are also high-end. You have the M6000, K6000. On AMD side, there's a lot of exciting news with AMD releasing its new line of cards. On an enterprise entry level, you have the 2100, the 3100, and 4100. All the way from 5100 and 7100 are called the Polaris-based cards. And the WX 9100 and 8200 are Vega-based cards. And we've tested a lot with 9100 and 8200. Still, one of my favorite cards before Navi release was the 9100. The latest cards that were released is Navi-based, which is W5700 and W5500. So if you're thinking about getting an AMD card right now as a new user, you should definitely watch out for the W5700 and the 5500. Yeah. Now, I've heard a lot of issues coming from the field about Optimus Technology. That is laptops that have both Intel graphics card and discrete GPUs. And we've heard complaints that, hey, I'm not able to turn on the graphics pipeline. We are aware of those issues. And there's definitely, we see there's some conflict between the Intel integrated graphics card and the discrete GPU. And the solution is sort of dependent on the OEM for disablement of the Intel IGFX. There's multiple options to, well, first of all, there shouldn't be any issues, where Solidworks is always configured to run on your discrete GPU. But in case you do find these issues, there are a couple of things that you can try. You can try disabling Intel integrated GPX on the BIOS. Or you can go to NVIDIA control panel. If you're using NVIDIA on Optimus, go to the NVIDIA control panel and select your discrete GPU to be NVIDIA. And then some future improvements. It's really fast, but we're doing something even more. We want to push the limits out here. And some of the more improvements that we're trying to do is on sketches. We're trying to do GPU-based silhouette edges. You guys might be thinking that edges it's edges. How difficult can it be? But in reality, edges are actually pretty complicated. It's even more complicated than shaded. We are also trying to improve performance with culling, occlusion culling, which will even improve performance for low-end hardware. And better image quality with PBR and better anti-aliasing. And also we're looking at better rebuild times for the graphics. And some of the related topics sessions that you may want to look out for are the technology for higher performance workflows with Intel. That's happening today at 5:30 to 6 p.m. And then there's another presentation today on how hardware affects performance of SolidWorks and Visualize at Davidson Ballroom between 5:30 to 6 p.m. With that, I'm ready for questions. Sure. Okay.
So when you're saying when SolidWorks complains about a driver update with their nVidia graphics card, what happens if Dell hasn't approved it yet? Because we like to push out our graphics card updates to Dell planned updates. But what happens if they haven't approved that update yet for your graphics card?
Yeah, so ideally, through the hardware certification page, that goes directly to the NVIDIA vendors graphics card download page. That is a move that we recently took because there were more bug fixes. The cards that we certify with NVIDIA, there's more quick fixes that NVIDIA pushes out. than the OEMs, than the hardware OEMs. So that's the recommendation, to go to NVIDIA's page and download the drivers from there. Yeah. Yes? Yeah. Yeah, so we found that for VDIs, that's actually an important topic as well. The performance is pretty good, but there's more complications out there that you need to talk about what is the cost per performance and stuff like that. We are testing and benchmarking, and yeah, that's something that we're looking into. Okay. Yes?
Just a note on that. I've been at a company where we deployed it, and the video performance was actually pretty good. We liked it, even though we didn't have a true cloud. We only had servers on one side of the coast, so the other side of the coast was not having it.
Awesome.
The problem that we found was not necessarily with the graphics cards, but with the software licensing with VDI accounts. We would buy servers thinking that was going to be the biggest cost, but it was all the licensing that went with it that was the big hitter. So you got to watch out when you do a true cross analysis on that if you go VDI.
Yeah. So he said that the issues were actually not with the graphics card performance, but with the licensing.
Yeah, on the cost side.
On the cost.
Performance side, it actually worked like a charm. So, until we went out to from one end of the coast to the other, we saw some millisecond lag that some people didn't like. But that was because we didn't have a true cloud with servers on both sides of the coast.
Box actually has a VDI set up in their booth, so you can actually test it. It's actually in North Carolina, so you can see what the latency is and everything else. It seems to move pretty quick. We actually ran some benchmarking on it.
Absolutely, yeah. Yeah, we need to get on talking about that after the presentation. Yeah. Oh, yes, please.
As the size of the large assembly grows, 12, 20, 32 gigs, something like that, will the graphics performance now scale if you put
Yes.
a better graphics card
Yes,
in?
absolutely. Correct. And right now we are pushing the GPU to its maximum extent, and we are utilizing the GPU to the full extent. So the idea is that you will scale if you get a higher-end GPU. Yes.
But we've done multiple tests that always prove that it made no difference, and now
So that's one of these. So that's the graph that we showed with the P2000 and a P4000 and a P6000. So these are from low end to high end, and you can see the performance scales. Yes? Yes? Yes?
How many of you were in general session yesterday morning when we talked about doing pop-up things like this and showing you some new functionality coming soon in SolidWorks? Anybody want to see some new things related to graphics? Yeah, a few of you? Cool. Can you help me? That's all right. Oops.
Yeah, sorry about that. Where is it?
Thank you. All right. How do I? Sorry about this. I'm not. There we go. So we talked about this yesterday, right? We're going to pop up in sessions just like this and do a quick little demo. So in case you missed yesterday, we actually did two of these. We did one on sheet metal right after lunch yesterday, and we also did one on assemblies. I heard some questions about large assemblies. That's a great one to go back and check out. Where can you find what we did yesterday? live.solidworks.com. You can go there and check it out. Our YouTube channel, Facebook, etc. All of this is being saved. You can come back and revisit it at any time. So if you missed any of those, go back and check them out. So in this session, I think everybody here is concerned about graphics, right? Everybody wants to do things graphically, maybe personalize, customize your appearances and whatnot. Well, the first thing you can do coming soon is customize your S key and things like that. Did you notice that little command search right in there? Makes it super easy to customize your interface. What do you do when you have this? Well, in SolidWorks, coming soon in SolidWorks, you can just use the new color picker feature to go grab whatever color you want. I'm sure many of you have figured out workarounds and whatever. Now you just click that button, go pick the color you need, RAW, Pantone, whatever it is, and you have that image. What if you need something off of a picture? I want to make it look right. I need it for rendering. I need it for all the other people who look at our designs. There's a lot of people who look at our data, right? We want it to look exactly right. Again, just go pick the color I need right off using the new color picker. Anybody in here do vintage cars, vintage any gear, recreating all of that stuff? Super. Just take a picture, pull it up, and you have all the information you need. In fact, anywhere you need to grab a color, an appearance, pick it. It's right here on your model. So this is cool stuff, fun stuff coming soon in SolidWorks. So stay tuned for that. Get involved in the beta event this summer, and check out more on SolidWorks Live as we pop up the rest of the day today and tomorrow. Thanks.